Good morning, everyone. My name is Nikhil and today is my topic name is Seminar Report on Lightweight Concrete. I am from Dr. Ambedkar Technology University, and my roll number is 19303391 so here we go. First of all, contents, introduction, principle of LWC, advantages, disadvantages, application, properties of LWC, methodology, case study, calculation, summary, and reference. So first of all, introduction. Lightweight concrete is a special concrete which weights lighter than the conventional concrete. Density of the concrete is desirably low, 300 kilogram meter cube to 1850 kilogram meter cube when compared to the normal concrete 2200 kilogram meter cube to 26,000 kilogram meter cube. Three types of LWC, that is lightweight concrete. First of all, lightweight aggregate concrete, adhesive concrete, and the no pile concrete. Principle behind lightweight concrete. First is the basic principle behind the making of lightweight concrete is by including the air in concrete. Second, to achieve above principle, practically there are three different types. Third one, by replacing conventional aggregate by cellular purpose aggregate in bracket lightweight aggregate. Fourth, by incomposing of air gas bubbles in the concrete. Fourth, by omitting the sand from the concrete, no file concrete. Then advantages, reduce the load of the building, easy to handle and hence reduce the cost transportation of the building, improving the workability, relatively low thermal conductivity, the good resistance of freezing and throwing action when compared to conventional concrete. Then disadvantages, very scientific, very sensitive with the water content in mixture, different places finish because of the property regularity of the aggregate. In some mixtures, cement mortar may spread aggregate and float toward the surface. Mixing time is longer. Conventional concrete assume a proper mixture. Lightweight concrete are porous and show poor resistance. Applications, since the strength of the lightweight concrete is low, it is used in construction of roofs, slabs, small houses with the use bearing walls, etc. It is also used in convention of stairs, windows, garden walls, etc. In large building also, this is used in a conventional of proportion walls, partition walls. There are modeled in the form of slabs and use thermal insulators inside the building. Lightweight aggregate concrete is basically of two types: natural aggregate and artificial aggregate. In natural aggregate, wet aggregate are less performed over the artificial aggregates. Important natural aggregates are pumic and soria. Artificial aggregates are usually produced by the expanding the rocks such as shells, salts, perlite, vermiculus, etc. A type of aggregate decided the density of the concrete. Density of concrete is lower than 300 kilo gram per cube can be achieved. Compressive strength of varies from 0.3 megapascal to 40 megapascal. Then natural aggregate and then we here we show natural aggregate, wet aggregate, artificial light aggregate. In natural aggregate, pumic, determine, soria, volcanic site, sawdust, risk husk. In artificial aggregate, artificial beads, cork beads, formed slag, bolted slag, expanded slag, and salt, sanitary flash ash, floximal exfolded vermiculite, expanded tropical geomorphical basalts. Properties of the lightweight aggregate. Pumic and soria are the volcanic rocks having the densities between 5,000 kilogram per meter cube to 9,000. Natural aggregate have good insulting properties but subjected to high adoption. Here we show some aggregates and their rocks. Then methodology, benching, wet benching, management of the water, preparation of the concrete cubes, compacting, curing, and testing. Then mixed design of the lightweight concrete, different to decide water cement ratio due to variable water absorption by the aggregates. Generally, it is done by the trial mixture. Pre saturation aggregate is done. Avoid excess absorption of water by aggregate. Then concrete with the saturated aggregate will have higher density, which is bad freezing and throwing action. In rare case, aggregate are located within with bitumen over the water problems. Here we see the block of the lightweight concrete, then mixed design of the lightweight concrete. Different decide water cement ratio due to variable water absorption by the aggregates, generally done by the trial mixing. Pre-saturation of the aggregate is done to avoid the excessive absorption of water in aggregates. Concrete with the saturated aggregate will have higher density, which is bad in freezing and throwing action. In rare cases, aggregates are coated with the bitumen overcome the absorption of the water. Here we show the contents of the content of the cube of lightweight concrete. Then case study, experimental study lightweight concrete by practical replacement of the coarse aggregate using the pumic aggregates, cement, ordinary Portland cement, 53 gauge with 29%, normal consistency of confining to IS code 8112 1989 was used. The specific gravity and fineness modulus cement is 1.14, that is the 5% pumic aggregate. Pumic aggregate is 20 size is used. Specific gravity pumic aggregate is 0.82. Coarse aggregate, crash stone course used, confining the IS 383 1987. The value losing the compared bulk density value. Courses aggregate is 4.417 kilo. Fine aggregate, river and sand are throughout the investigation as a fine aggregate. The properties of the sand and conducting test according to IS 2386 part 1 1983, the specific gravity, fineness modulus, moisture content were decided. Water is the important ingredient of the concrete in activity participations. Chemical reactions with the cement clean. Portable water, confining IS 456 2000 was used. Concrete mix design in the present study, M25 grade with nominal mix as per IS 456 2000 was used. Concrete mix proportion by weight for cubic meter and water cement ratio of 0.5. After that, conclusion is strength value is compared to the normal concrete, and replacement of the cursed aggregate by pumic from different pages for 50, 60 and 70. Maximum value of the strength obtained in 60, replacement by the pumic with coarse aggregate. Concrete with 60% replacement of pumic compressible strength, the comparable with the normal concrete. And this type of concrete can be utilized in walls, panels, non-loading bearing, in painting of building. After that summary, by 60% of lightweight concrete aggregate as a particle replacement of NCA, the compressive strength is promoting. The density of the concrete is found to be desirable with the increasing percentage replacement and normal aggregate pumic aggregate. The compressive strength of the concrete is found to be increased with the decrease in pumic concrete. With the addition of material mixture, the compressive spill, tensile and flexible strength of the concrete are increased. Lightweight aggregate is a way inflated natural coarse aggregate, and it can be used to consumption purpose. Thank you.